All right. Symbols. Just a quick symbol review. Mean versus standard deviation. All right, if it's a sample, what's the symbol for sample mean? It's an X with a what?
Bar.
What's the symbol for population?
Mu.
It's that Greek letter, mu. So you and I right now, you go, what is this? We're just getting organized. See what all these symbols are. Now we know this letter. What's this?
SX.
S. If you want to put a little X on the subscript, you can. It's an S. And now I'm going to show you this one. See when they call these populations, they call them parameters. And they use Greek letters. So you bet, this is going to be a Greek letter. The symbol for population, standard deviation, looks like that. You go, what's that in the Greek alphabet? That's lowercase sigma. That's sigma. That's not the uppercase, it's the lowercase. Just like we have capital A and little a, like lowercase, like, that's lowercase. But it's sigma, it's lowercase sigma. So you can just call it sigma. But it looks funny. When I was a student, everyone, I didn't know the Greek alphabet, I'll be honest. Years ago, I just called it O. It looked like an O. I'll go, your S, your U, your X with the bar on top, you know, the X hat. Made up names. Cool. Now, the formula for this, I want to show it to you. It's the same thing as this, except for one thing. It's the same thing. By the way, you don't subtract X bar. What do you subtract?
Mu.
Mu. But you don't do the n minus 1. You just divide by n. That's the only difference in a population standard deviation calculation. You don't divide by the degrees of freedom. You just divide by the what? The big N. You remember what big N meant? Size of the what?
Population.
Population, yeah. And a lot of times, isn't big N in the millions?
Yeah.
Right? A lot of times, big N is in the millions. So if you divide by 1,000,000 or 1,000,001, that's not going to be a big difference, is it? Yeah, that's what I mean. That's what you get a sense of. But when it's small, when there's small sample sizes, it does have an effect. Cool. Oh, I got the way I need to copy. Hey, if you're curious for your next test, I won't have you calculate a population standard deviation. I'm going to have you calculate a sample standard deviation. All right? I just want to point that out. You're curious. You're like, you're going to make me do a population? You're going to have to calculate a sample standard deviation. I'll give you a sample, and then I'll ask you to calculate the standard deviation of that sample if you're curious. Cool? All right. Super job.
Will we have to know the formula or just have
No, these get attached. You know? But I'll be honest, I think you're probably not going to look at that. I'm serious. Watch. You can be like, I'm just going to calculate. What's important is, rather than the tedious calculations, you know there's a formula for it, you can do it. It's understanding, like, what does it mean? Right. That is really the thing. It's like, I want to be statistically literate. I can look up the formula, but what does it really mean? It's like, on average, it's giving me how much, you know, the average deviation from the mean of each one of these observations. Awesome. Hey, before we play around with the calculator, let's do an exercise. I'll erase these formulas. I was just talking about statistical literacy. I want you to be statistically literate. And so I'm going to give you a little exercise. We're going to come up with a solution. I gave some tests last week to the students down the road, right? As a midshipman. Well, this was the result of the test. All right. I put some symbols down. All my students, all midshipmen, that's what they got. This was last week on midshipmen. X bar was 52, it was out of 100. X bar is 52, S was 7. All right. Now, I handed back the tests. Student goes, hey, professor, can I ask you about number 2? I looked at number 2 and I'm like, you know, you're right. He was making an argument for number 2, you know, the wording used. I said, you know, you're right. So you know what I'm going to do? Number 2 is worth 5 points. And I said, I don't care if you got it marked right or wrong, no matter what, this is what's going to happen. Every student is going to get 5 points added to their score. Okay? Every student took the test. Everyone's going to get 5 points added to the score. You Susan's gonna get it, Joe's gonna get it, John's gonna get it, David, etc. Everyone's getting 5 additional points. All right? So 5 additional points are being added. To each grade. All right? You're going to help me come up with these 2 numbers. Now, if you know it, don't shout out. I want you to start thinking about this. All right. Because I know what you're thinking. Some people in the room right now are going, how many students are in the class? How many students are in the class? We don't need that. Because I said each student, right? Each grade. Each one of the students' grade got 5 points added to it. So, remember what was going on before? I'm going to use my hands. Everyone, here's that 52. It's in the middle, right? There's that 52 in the middle. And on average, everyone's about what? 7 away from the mean. This is like the distribution of grades, right? There's the very lowest, the min. There's the highest. But on average, they're about roughly what? 7 away from this what? 5. And everyone got a 5 added to it. When I do that, this whole thing's going to basically shift like this. So, what do you think the x bar is going to be?
57.
You nailed it. Everyone agree? Everyone got 5 points added. What's going to happen to the average? It's going to go up by what?
5.
5. 57. If Joe got it, Sue got it, David got 5 points, and what's going to happen to the average? That's going to go up by 5 points, right? Now, before you come up with this, I want you to watch my hands again. Okay? All right. Here's the grades before I add the 5 points. In the middle is a 52, right? Now I added the 5 points. Remember, standard deviation, we're thinking of the spread of data. Watch the spread between my hands. Shh. Now the grades are here. I want you to look at the difference, the distance between my left hand and my right hand. I'll do it again. It was over here. There they are. There's that 52 in the middle. Now everyone got 5 points added to the grade. Shh. What about the distance between my 2 hands?
Decreased.
Didn't change.
Oh,
What's going to
decreased.
happen to this standard deviation? It's going to stay 7. Now everyone's on average 7 away from the what? 57?
Yeah.
Yeah, statistically literate. We get that. We understand that. Very good. There you go. You nailed it. Okay, the mean went up by 5, but the standard deviation stayed the same. Stayed 7. Cool. Awesome. Hey, let's go to technology. Let's go to calculus. Absolutely. You can use this throughout the course to facilitate the tedious calculations. I'm going to hit this slide, okay? I'm going to put you to sleep. All right, the first thing is, I need you to find the stat button. I'll hold it up like this, the stat button. It's up near the top in the middle, the stat. And I'm going to hit stat, and you get a menu like this. And I just want you to hit enter. See how it's on edit? Just hit enter. And you get something like this. Now, a lot of yours might be blank. That means no data in there. You see how I got data in here? Who's got blank data? It means awesome. So you get the enter stuff in right away. I got stuff in the way. I got to clear this out. So what I do is, I'm going to use the up arrow. And I'm going to up arrow to that L1 right there, right? I'm going to hit the button clear. If you can, on your paper, would you write down clear? It's a good button. I'm going to hit clear. Where's clear? It's right near the lower arrow. Want to see clear? So I'm going to hit clear, and here I go. Watch me do it. Clear. Now, did anything happen? No, because now I have to hit enter. So I want you to know that. So you go, why did anything happen? I have to hit enter, and boom, boom. Cool. But warning, if you go up there and you accidentally hit the word, I should whisper it, delete. If you accidentally hit delete, guess what's going to happen? You're going to remove L1 from your calculator. Okay? I would bet, $100 it'll happen to at least one student in the class. It always happens. I think it's a design flaw. They shouldn't allow it to happen so easily. If it happens, would you just see me? I can help you get it back. It's not hard. So if you're like, I lost my L1, let me know. All right? I know on a test I won't be able to help you. You go, what will you do? Just use L2. Just use L2. Just don't delete all of them. Right? But yeah, use clear, right? So if I wanted to clear this out, what do? I hit clear, and then what do I hit? Enter. There you go. So we're going to go in here. What were the numbers from our data set before? 1, 2, 3, 4, and what? 5? All right, hit that. Hit 2. Hit 3. Hit 4. By the way, to make it move, I'm hitting enter. Hit 5. Type them all in. All of those are now L1. You bet. You can use L1 over and over in this course. And when we need 2 columns, we use L1 and L2. All right? All right, everyone done? Hey, unfortunately, there's no like escape button here. Like to leave this, almost like it's like a web page. There's nothing here to leave it. So what I always say is quit. So you know where quit is? You're going to hit that second mode. So I'm just going to quit out of the screen. So I'm just going to hit second mode. Mode is right next to the second. So to get that quit, I have to hit this second, and then mode, and it goes up. I just want to say, all right, it's all in there, right? Now I want this tool right here to do some things for me. I want to get the sample mean, and I want to get the sample standard deviation, right? Okay. So I'll go back in, back to stat. Now I'm not going to hit enter this time, am I? Because I'd go in a circle, wouldn't I? I go back to stat, and when I want to arrow to the right to that calc. So use the right arrow and go to the calc menu. So calculate. And it's number 1 on the list. So if I want this, there it is. It's called one variable stats. I'm just going to hit enter. Nothing happened because I have to hit enter again. So remember that. When it does that, I hit enter and you get this. I just hit enter again. And everyone, you can use your down arrow. This list goes really far. Goes down a ways. So you can use that down arrow if you want to look at everything. Look at that. How far it goes down? What's those Q1s and Q3s? That's coming up after test 1. We'll get to that later. But what I love is, does it give us the median?
Mm-hmm.
Awesome. Does it give us the sample mean?
Mm-hmm.
Everyone see X bar? And does it give us the sample standard deviation?
Mm-hmm.
Awesome. Hey, do you notice? There it is, 1.5. Is that what we got? 1.5? There it is. Do you notice it does a population standard deviation formula?
Yeah.
That was where you just divided by, that would have divided by 5.
Obvious.
But hey, remember I said in your task, which one am I asking you to find?
Sample.
Just so you're not stressing about that. I'm going to have you find the sample standard deviation. I'm not going to give you like a million numbers and go get the standard deviation. Right? Give you a group, it might be like 20, 25 numbers.
Mine's not coming up on mine.
What's that?
It's not coming up on mine.
It's not coming up on yours? Let me see it real quick. I'll fix it. So you come in here and you go in here and let's see what you got. So you're down here, you get list 1, and then you're going to just go down to calculate. There you go. You're welcome. Hey, so that was a good question she just asked. Who has a newer model? And what happens on your newer model? When you went that screen, you had to go down arrow to a button called calculate. So you figured out, everybody else have the newer models? It might be at home or something, I just want to let you know that. It's not exactly like you saw. When you went to that screen, I hit enter, it would have another screen that goes, I think it said list L1, and it said calculate, you would hit calculate. And I'll do it for you. Cool. Hey, can you use this on the test? Yes, I encourage it actually. Because more important than the tedious calculations is what? You know, you can do it by hand. But everyone, what if I had you do 40 numbers? And the numbers were like 6.825 and 22.90. Could you imagine how long that would take, that process? I better give you an hour for one problem, do you agree? You follow me? So that's what's more important than the tedious calculations is the understanding of what it means and what it means. Cool? All right. So you can use that. I encourage you to, especially when you get a bunch of numbers. But see, you understand the concept of standard deviation. You're statistically literate. So without that tool, now if you know this answer real quickly, would you hold off from letting everyone know? Give everyone a chance to think about this. Standard deviation. All right. You're not allowed a calculator in this one. I want you to find the standard deviation of that set of group, of the set of data. Now don't shout it out, but who already knows the answer? All right. Take some time to think about it. I want you to find a standard deviation of that group. Standard deviation, like what does that measure? It measures on average how far each observation is from the what? The mean, right? Okay. Well, I have an 8 and an 8 and an 8 and an 8 and an 8, right? But you and I, we're going to be statistically literate. We're measuring the sample standard deviation of this. Okay, well, 8, 8, 8, 8, 8. I'll find the mean. What's the mean?
8.
The mean is 8. Is that right?
Mm-hmm.
Okay. And now I gotta figure out how far away each one of these values is from a what? An 8. Who thinks they have an idea of this number without even writing stuff down as you're thinking about this? Because I'm gonna have to take that, subtract that, hit that, subtract that. Did you have your hand up? Oh, what's your name? I'm sorry.
Krista.
Oh, Chris, what do you get?
I think it's 0.
0. That's the standard deviation. That's the sample standard deviation. 0. 0 deviation, right? Everyone agree? How far away from me? 0. They're all right on the mean. Does that make sense? There you go. See, that's what I mean. That's more important than like, just crunching through all the math numbers. We're like, you get 0. It's all around the same. Hey, last thing we do, you're gonna like this, is we're gonna talk about the empirical rule. It's the last thing in section 3.2. It's called the empirical rule. All right, and this deals with bell-shaped distributions. It deals with bell-shaped distributions. All right. Can I erase the range formula? That's easy, right? Max minus min. Well, the empirical rule deals with bell-shaped distributions. What is the empirical rule? It's 3 numbers. Here they are. 68, 95, and 99.7. And they're percentages. So I should put percentage symbols next to these 3 numbers. 68%, 95%, and 99.7%. 68%, 95%, 99.7%.